All right, let's look at the solutions of this derivative gate exam here. A lot of product rule, quotient rules, and chain rules going on. So this first one, whenever we see this simple fraction here with just a power of x on the bottom, let's go ahead and rewrite this with negative exponents. That'll help a little bit there. So we've got x to the sixth cosecant x minus x to the negative 1. And now we can go ahead and attack this thing. So we've got a product rule going on. We've got 6x to the fifth times the cosecant, so derivative of the first times the second, plus the first as it is, that's a 6, times the derivative of cosecant, which is cosecant and times cotangent. All right. Now we can minus derivative of the second part. Well, I'm going to drop down the negative 1, and we'll have negative 1. It's going to be x to the negative second. Well, let's go ahead and make this into a plus negative. And let's go ahead and only simplifying what we're really going to worry about right now is putting that into positive exponents. Okay, we're not going to worry about rearranging and factoring right now. That'll be good. All right. How about this guy? So we've got a natural log. Anytime we have a natural log, it's a good idea to rewrite it. Now, there's a couple ways to rewrite it. I'm going to go ahead and rewrite this with negative exponents. And then we've got this log rule that says exponents inside the log can come out. And we can write this as negative 7 times the natural log of x. And now when we take the derivative, y prime, we just have the negative 7, which doesn't change anything. That's a constant. And then we have, what do we have? We've got the derivative of log of x, which is 1 over x. And we can write that as negative 7 over x. Might be a little neater. That's it. On to the third one here, we've got some quotient rule. So we take y prime, derivative of the top, sine is cosine, times the bottom. And that's minus the top times the derivative of the bottom. Derivative of the bottom is derivative of e to the x is just e to the x. Derivative of x squared is 2x to the first using the power rule there. Okay. And that still using the quotient rule. Okay. Going back to our quotient rule says derivative of the top times the bottom plus the top times the derivative of the bottom. That's what we just did. All over the bottom squared. So let's just put those in some parentheses. And take that bottom part squared. Okay. And here we have one with a quotient rule. So we have, actually it looks like a quotient rule. Sorry, we don't actually need to use a quotient rule because there's no x down here. So you could use it, but you're just going to have a derivative of 4, which is 0. So let's avoid that. We don't need that. Let's rewrite this. So rewrite, pull out the 4 as a 1/4 because it's in the denominator, times the natural log of the secant squared of x. Now let's use that log property. And you can do this as a chain rule, but it works real nice to bring this out. So if we bring this 2 out, we have 2/4 natural log of secant of x. So might as well use all the math we know, right? So those log properties can be really useful. Now we can take the derivative, and the 2/4 is going to hang out. Now the derivative of log of u is going to give us, we have the derivative of the inside, that'd be secant x, secant tangent, all over secant x, the inside there. And these guys cancel, and that leaves us with 2/4, which we can go ahead and simplify as 1/2. So that's just going to be 1/2 tangent of x, or tan x, over 2. There you go. Simple simplifying we can do there, right? All right, on to number 5. So this is a quotient rule because we have a function of x on the top and a function of x on the bottom. So y prime, we have derivative of the top times the bottom minus the top times the derivative of the bottom. Now, derivative of 2x is like e to the x, where it doesn't change, but then we've got to multiply it by that conversion factor of natural log of 2. All right, all over the bottom squared, 2 to the x squared. All right, now since our rules that we've given for this little test is that you don't have to simplify, you could leave it like that, but this leads to a nice simplifying here. If we cancel those out, we have a 2 to the x here, a 2 to the x here, and a couple 2 to the x's here, and so we could cancel those out and write that like this. Just cancel 1 2 to the x out of each term. Okay, there's that. Good deal. Well, moving on here, now we've got an implicit derivative, or really in an implicit function that we need to do implicit differentiation. What makes this implicit? Well, we have x's and y's all together in the same function. So it's not solved for y. So we just attack this like we do with x's. However, we've got to watch out whenever we take the derivative of a function of y, we've got to remember that y is a function of x. So we're going to need the chain rule. So we got product rule here. Derivative of the first is 2x times the second, which is just y squared, plus the first times the derivative of the second. Now to do the derivative of y squared, we're going to treat it like a chain rule. Take the derivative of the whole thing, which is drop the power down, subtract 1, which makes subtract 1 from 2, leaving 1. Then we've got to multiply times the derivative of the inside. Well, what's the derivative of y? Well, that is y prime, or dy dx. Great, so we're done with the product rule there. Now the derivative of cosine y. Derivative of cosine is negative, so let's go ahead and make this let's go ahead. Negative sine y, and then we've got to multiply that by y prime. That's the chain rule. Okay, we've got another product rule over here. So let's do the product rule. Derivative of the first is 1 times the second, y cubed, plus the first times the derivative of the second, which is 3y squared, times the derivative of the inside. Got to do that chain rule anytime we have the derivative of y. Now, our goal is to find the derivative of y here, to find y prime, and it's all mixed in. So we've got y primes here, y primes here, y primes here, all right? So we've got to move things around, all right? Let's bring, you can choose. Let's go ahead and do this. We got some y primes on the left, some terms with y prime. There's all our y primes. Let's leave those on the left, and let's solve it. Let's bring this one over here over, and that's going to give us, rearrange here a little bit, x squared times 2y. Let's go and bring that 2 out here. 2x squared y prime minus sine y prime. And we'll bring over that term from the right, 3xy squared y prime. And then we're going to move these that one over to the right so that all these two terms are over on the right. So that gives us this y cubed, and we're going to have a minus 2xy squared because we're going to subtract that from both sides. And we're almost there. Now we're going to factor out this y prime and leave us with 2x squared y. After a little practice, you don't have to write down all of these steps once you really see what's going on. All right, and that's equal to y cubed minus 2xy squared. Okay, and now we got to solve it for y prime here. So last step, let's divide both sides. And so we have y prime equals y cubed minus 2xy squared all over 2xy minus sine y. We'll give you a little more room for this problem on the next gate exam. There we go. All right. But really, that's a lot of steps we don't need to show. So there you have it. Next one. Got a couple things going on. A whole lot easier when it's not implicit. So we've got, first one is the chain rule. Derivative of the inside, derivative of cotangent is negative cosecant squared times the outside. Well, derivative of e doesn't change. E dx, that is. Now we have a log, not a natural log. So since it's not a natural log, we're going to have a conversion factor down here. Whoops, log of 4. Natural log of 4, that's our conversion factor. And then we take the derivative of the inside, that's 6x plus 1 all over the inside. Natural log of 4, that is, times the inside in this case. X plus 1. That's it. That's a quick one. Number 8. Okay, good idea. First of all here, let's, well, we can rewrite, or we can just think of this as x to the 6th. We'll go ahead and rewrite x to the negative 6th, right? And all of this isn't going to matter. So I'm wasting my time rewriting here, because look at all this stuff on the right. Are there any x's? I don't see any. There's no x's. There's no variables. So whatever this is, it's just a constant on the right. And remember, when we take the derivative of a constant, it's 0. So the whole point of this guy is, doesn't matter how ugly that is, the derivative of that part of it is 0. So y prime is, and that right side is going to just go away. We don't care about that because there's no variables. So the derivative of cosine, we got a chain rule here. So we're going to have the derivative of the inside, which is going to be negative 6 times e. Subtract 1, you get 7. So it'll be negative 7. I'm going to go ahead and write that as a fraction here. And then on the bottom, we got the derivative of cosine is 1 over 1 minus x squared, or the inside squared. And so the inside squared, that'd be x to the negative 6th, or 1 over x to the 6th squared. Now one more thing, the derivative of cosine, a little reminder over here. So the derivative of inverse cosine is of x, let's go simple, is negative 1 over the square root of 1 minus x squared. So hopefully we have that memorized. So I need my negative 1. This negative here came from that negative 6, but I need my negative 1 for this whole cosine, and so that's going to make this negative 1. So I need to multiply by negative 1 on the top. Just going to take that negative out. So there you have it. We could clean it up more, but that's good enough. Right there. When we get into more applications of derivatives, you'll need to clean that up. So this one's pretty straightforward. Quotient rule. derivative of the top, so y prime, derivative of the top is 8 times the bottom minus the top times the derivative of the bottom, all over the bottom squared. And this one does simplify pretty nicely. We don't have to, but since it's some pretty quick simplification, let's do that real quickly. We have, now if you distribute this out, you're going to have a 32x, and you're going to have a minus 32x. Those are going to cancel. You'll have an 8, and you're going to have, distribute this minus in that 4. That'll be a plus 4. So that's going to be a 12. So this one does clean up kind of nicely. Let's go ahead and do that. And we don't, when we simplify functions using derivatives, we don't want to multiply this out. Simplify doesn't necessarily mean get rid of all the parentheses. It means more we want it in factored form, because factored can be solved easily. So that would be our simplest form there. So that we'd want to stop at. So, all right, number 10. Last one, we've reached the end. So we have an inverse tangent. And so y prime, inverse tangent is 1 over 1 plus x squared. And since this is a chain rule, we need the derivative of the inside. 7x to the 6th, all over 1 plus the inside, which is x to the 7th squared. Okay, and if you want to clean it up, which is optional in this case, we have 1 over 1 plus x to the 14th. I'll put an or there. All right. There you have it. There's your GATE exam. So study those, practice those. Remember, the key is to recognize the quotient rule when you see it. Recognize the product rule to functions that are being multiplied. And then recognize the chain rule. So when you got a function inside of another function, that's the chain rule. Obviously, you're going to watch out for our implicit. That takes a few extra steps. And one more reminder there, 2 more reminders. One, when you have a fraction, it can be easy or helpful to write this as a negative 1 power, or negative powers, that is, exponents. And then also if you have a log, little reminder there, it can be helpful to use your log properties first, make it into a simpler function that you can take the derivative of easily. So keep working on those. It'll come. Don't give up. It just takes practice, and that's the whole point of a GATE exam there. So keep working hard. You're doing great.